Hello and welcome back to the lecture on applied econometrics. We have been talking about autocorrelation and we have been talking about different tests to identify if there is autocorrelation present in my data. Now, we have to, just knowing is not enough, we have to find a remedy to the problem. And in this lecture, we're actually going to talk about the remedy of autocorrelation. And as I told you previously, that one very important remedial measure that we take to sort of get rid of autocorrelation is differencing. So we'll see how we actually, what is differencing and how we actually perform it. So let me write down differencing. Let me use a different color. Differencing technique we'll talk about. Differencing. Now, let's again go back to the previous example that we had that we used when we sort of used consumption data in the United States, and we wrote it as, let's say, my consumption CT, consumption in time period T, is equal to, let's say, beta 1 plus beta 2 into wealth, or TH, beta 2 wealth, beta 3 income, and let's say there's some disturbance term UT. Okay, so this is wealth T, income T, and UT. So time series data. Now, if I take this model at T minus 1th time, so then it will be beta 1 plus beta 2 wealth T minus 1 plus beta 3 income T minus 1 plus UT minus 1. Okay, now let's remember that. Let's remember the AR1 process. A way to sort of understand the relationship among the error terms. So if I write down an AR1 process, and in that AR1 process I wrote down that UT is related to the previous period error term, and I can write UT is equal to some rho into UT minus 1 plus some innovation term ET, which is an IID. Okay, and here what is happening, since I have autocorrelation, I'm sort of assuming that in this AR1 process my Tth period error term is only related to my T minus 1 period error term, which is UT minus 1, and the correlation between this correlation coefficient between these two is basically rho. Okay, so now look at the previous two equations that I've just written. This is 1, this is 2, and this is 3. Now if I try to see that actually if we can remove this UT or UT minus 1, so then we can actually possibly get rid of the sort of the pattern of the error. So in fact, if I write down this AR1 process as UT minus rho UT minus 1, all I'll be left with is that innovation term, which is IID, right? And then I do not have, it is absolutely random, and then I do not have any problem in having an OLS model. So basically then I will be able to get rid of the autocorrelation present in the data. Now if I want to achieve that, what I have to do is essentially I have to basically multiply equation 2 with rho, right? So if I further reduce the font, so let's say, let me use a different color, multiplying 2 with rho, and then subtracting it from 1. So let's say 1 minus 2 rho into 2. If I do this, what I get is CT minus rho CT minus 1 is equal to beta 1 minus rho, beta 2 into, I will have wealth at T, period T, minus rho into wealth at T minus 1. Then I can further write beta 3 plus, let's say, beta 3 income minus rho into, sorry, income at Tth period, rho into income T minus 1th period. Okay, so that's what we will get, and if we can do that, essentially I will be able to get rid of the UT terms. Okay, and then I will essentially have only my random error present in my model, which I basically want. Now, in order to achieve this, so this is simply the technique of differencing. Now, in order to achieve this, so there is a challenge in terms of finding the row. How would you find the right row? Okay, and we know the value of row actually varies between. We all know it is between -1 to +1, and then you can do one thing. You can actually sort of substitute different values of row and see how where you can basically you can plot this data and you can see, or you can actually adopt other tests like Darwin-Watson and Bruce-Godfrey and see if you still have autocorrelation present when you actually get this new equation. Okay, now that is one way of doing, but in this case what you need to do is you need to sort of do a lot of trial and error. So this is equation 5. So you need to do a lot of trial and error to identify the right row, but this is a doable process. There's a little bit of hard work you need to do. The other way you can sort of you can actually do is basically you can run a regression and between ut and ut minus 1 and identify the value of row. Okay, you can actually identify the value of row. There are other possibilities also. You can actually have that if it is an AR1 process, you know that the Darwin-Watson statistic is nothing but, or let me write following the same convention, dw is almost equal to 2 into 1 minus rho. Now if you get the value of Darwin-Watson statistic, what you can do, you can basically get the value of rho. So rho is essentially nothing but, rho is going to be Darwin-Watson, so basically it will be 1 minus Darwin-Watson statistic by 2. Okay, so that's the value of rho you're going to get. So you can use the value of rho to sort of get your equation 5. Okay, now let me actually show you the data. Okay, so let me actually show you the data. We'll be using the same data that we used previously. So let me actually take you to this data. Let me take you to the data editor. Let me actually show you the data editor. So if I go to the data editor, you can see now we have data for, wait a second, data editor. So for some reason it is not showing this data editor. Let me give me a moment. Okay, here we have this data editor, and in this data editor we can see actually we have this consumption, income, wealth, all these variables as it is, interest, and then we have taken the log of it, log of consumption, log of disposable personal income, DPI, so it's essentially the same log of income, and then we have log of wealth. But then what I have done is I have actually subtracted consumption, log of consumption from the previous period. So essentially, so log of consumption in this period is 6.88, here it is 6.905. So if I take a difference, it is going to be 0.021. Okay, similarly for the next period, what I have done, it is 6.93, it is 6.90. So if I take a difference, it is going to be something like 0.026. Similarly for the next period, it is 6.99, it is 6.66. If I take a difference, it is going to be 0.06. So that way I have kept on taking difference between two periods, exactly the way we have done, right? Similarly for other variables also I have taken the same difference. And note here, I'll just come to this point. So note here, rho, the value of rho is 1 here. So essentially I'm just differencing one period value from the past period value. Okay, so if we do that for log of disposable personal income, so it is going to be ln consumption of this period, ln consumption of that period. So essentially if I take a disposable personal income, it is this is this period 6.94, it is 6.99, and if I take a difference, it is going to be 5. Here again it is 6.999, here 6.993. If I take a difference, it is going to be 0.005. The next period is 7.083 and it is 6.999. So if I take a difference, it is going to be this 0.005. 0.08, because 7.08 minus 6.99 is going to be 0.08, and so forth. So basically you take difference between two periods, t and t minus 1th period, okay, exactly the way we have seen in our equation here, right? So here we have taken tth period and t minus 1th period, and we have multiplied the value of rho. Now what I sort of mentioned is that the rho in the previous data set, what you're seeing in the data set, the value of rho is basically 1. Okay, now why do I take the value of rho is equal to 1? Now there is a good reason why we take value of rho is equal to 1, and that is because when we think that there is a high correlation present, autocorrelation is high. For high autocorrelation, we may take rho is equal to 1. Okay, rho is equal to 1, but it is again it is just a experiment basis. You can take rho is equal to 1 and you see the results, and you can plot the data, and you can actually do the tests and see where you stand in terms of removing the autocorrelation. But on the other hand, if you can also use this different tests like Darwin-Watson test, or you can actually run the regression on ut minus 1, and you can actually find out the value of rho, and you can substitute the value of rho and see what is happening. So for example, in our data set, let me actually show you. In our data set, we also have identified the value of r or rho, and if I see, I have actually taken this r, okay, this r or rho, and I have after obtaining the value of r, what I have done is I have multiplied r with ln consumption, okay, or ln dpi and ln weld, and once I do that, I have basically sort of do the subtraction again with from the original value. So this is how we sort of remove the autocorrelation present in our model. Now one more point that I need to tell you is that, let me actually go back to the whiteboard, is that you can talk about, we can sort of make sense when we say that we subtract the value of the past period value multiplied by rho, and we get sort of our model error free. But then again, we have to kind of think that we are talking about, in this case, we are only talking about AR1 process, okay, where my rho is only related, my error is only related to the past period. But it could be, let me use a different process, different color, AR2 process, where my ut is actually basically nothing but rho 1 ut minus 1 plus rho 2. Here I do not have a constant rho, I have a rho 1 and rho 2 ut minus 2, okay, plus some error term. Now in this case, the simple formula may not work, so we have to do a little bit more iteration. But usually when you use software, you usually can mention AR1 process or AR2 process, and software is smart enough to actually identify some value of rho 1 and rho 2 to see where you can get the model almost error free, where you can actually, it can actually plot the data, or it can actually do the tests to sort of give you the right value of rho 1 and rho 2. For more details, I will not cover more details on this. So for more details, you can actually follow Damodar Gujarati's book, Econometrics by Example. There are some more tests provided. You can look into that. But this is essentially the concept how you can get rid of autocorrelation problem using the differencing technique. So with this, we end this lecture here. Thank you.